So this one is Unit 2 from Jan 2022 component of Unit 2. Which are correct for this equation? First thing, enthalpy change negative. So when enthalpy change is negative, it must be exothermic reaction. And this is an alkali and this is an acid. So acid is reacting with an alkali. So when acid react with an alkali, what we call these reactions, we call them as neutralization. So this is a neutralization reaction. Which equation does not represent the standard enthalpy change of atomization? Sorry. Standard enthalpy change of atomization means when we produce atoms in a gaseous state. 1 mole of atom, like there should be 1 mole of atom, and the condition it should be in a gaseous state. This is 1 mole of atom, this is 1 mole of atom, this 1 mole of, but this is producing 2 moles of atom, so this is not atomization. Like it is twice the atomization of chlorine because we want 1 mole of a gaseous atom. That is atomization. 5.2 grams of a sodium hydrogen carbonate was added. The temperature increases and the energy change calculated to be 1030. What is the enthalpy change per mole? So enthalpy change per mole is energy divided by moles. Energy should be in kilojoules, so we divide by 1000 to convert this into kilojoule. So it will be 1.030 kilojoule. And what about the moles? Moles equal mass in gram over molar mass. So mass in gram is 5.2 and the molar mass is 84. That's given to us. This will give us the moles. And enthalpy divided by this will get the enthalpy change per mole. Because the temperature is increasing, so reaction is exothermic and the calculated value will be 16.6 kilojoule per mole when we simplify this. So energy, when energy is given in joules, don't forget to convert into kilojoules. The next is the bond enthalpy we need. So bond breaking energy. We need the bond enthalpy for OC, this one. So this is X, this one is X. OC for methanol we need, sorry, methanol. So this one is unknown, this one is X. CH is 430, so this will, bond breaking energy will be X plus twice of 413 because this is 413 plus O double bonded with O, 498. So this is a 49 bond breaking energy. The bond forming energy, OC is 805, but 805 multiplied by 2 plus OH is 464, so 464 multiplied by 2. And the enthalpy change for this reaction is minus. So bond breaking energy minus the bond forming energy is equals to enthalpy change. Bond breaking is X plus, this will be 826 because multiplied by 2 plus 498. This is a bond breaking minus the bond forming. So this whole will be 2 multiplied by 805 plus 2 multiplied by 464. And this is equals to enthalpy change minus 591. So we have to simplify for X like mathematical equation is formed. And then we just have to simplify for X to work out what is the bond enthalpy for OC bond. That will be A 623 after solving. Now it is just a mathematical equation. You just have to solve for the value of X. Which sequence shows a molecule in order of increasing the boiling point? So to check the boiling point, what we have to do, we have to check like the type of the intermolecular forces that exist between the molecules. So remember like that graph, water or should have the water is there, ammonia is there, hydrogen fluoride. They should be at the top because they have hydrogen bonds. So in the highest boiling point in this case, it should be water. So either D can be an answer or B, because that is the highest increasing order. Then the other molecules like CH4, Cl2, and Br2, they all have induced dipole force. And dipole induced dipole forces increases as the number of electron increase. So in case of a methane, how many electrons will be there? Carbon is 6 electron and hydrogen 1, so total will be 10 electrons. Each chlorine is 17, so 2 will be 34 electrons. Bromine is there. When you check the periodic table, 39, I guess, for bromine, 35. So bromine is 35 and then 35 multiplied by 2. Because dipole induced dipole forces increases as the number of electron increase. So 35 multiplied by 2 will make 70 electrons. So this is the order is correct. And the highest should be either if it was water molecule, ammonia was there, or hydrogen fluoride. So water molecule should have higher. The highest is water molecule. Then we have hydrogen fluoride. When we compare, because even though the hydrogen bond is stronger in hydrogen fluoride, but there's only one hydrogen bond formed. So that's why the boiling point of water will be greater in hydrogen bonding as compared to hydrogen fluoride, and hydrogen fluoride will be smaller than ammonia. So D will be the right answer, as they have dipole induced dipole forces which increases as the number of electron increase, which is not correct about the ice. So this is about the structure of ice. When we compare, ice has a lower density than water. That is correct, because that's why the ice float on the surface of the water. H2O molecules are further apart in ice than in water, because what will happen in case of when the molecules have a large spacing between them, as in case of a solid state, when ice is formed, the spacing between the molecules increases. So when the spacing increases, the density will decrease. And as the density decreases, so it can easily float on the surface. HOH bond angle is same as the angle, HOH bond angle is same in ice as in water. When we compare the bond angles, because the geometry, when they're in a liquid state, they have a different bond angle. When they're in a solid state, they have different. So in that case, why? Because if the bond angle was same, then the geometry. So when we compare the bond angles, if the bond angles were same, then what should happen when they arrange themselves? They should have the same density, like density of the ice and the density of water should be same. But because the bond angles are different, that's why this statement is not correct. And H2O molecules in ice are held together by a hydrogen bond. So hydrogen bond is there because when hydrogen bonded with oxygen, so there's always a hydrogen bond. So this one, if they were having a same bond angles, it means that the density, the structure or the geometry of the molecule is same. As a result, they should have the same density as well. Which intermolecular forces exist between the molecule of this compound? So there is OH, so there must be hydrogen bond. There is C double bonded with O, so there will be a dipole. And about the London dispersion forces, it is because as there are electrons, so London dispersion forces are always there. So hydrogen bond is there, that's right. Due to carbon chain or electrons, dipole, induced dipole or London forces will be there. And because of carbon and oxygen partial negative and positive, there will be permanent dipoles as well. This question is about alkanes. Which of these alkanes has the highest boiling point? The boiling point of alkane depends on the number of the carbon and the type, like it should be straight chain and highest number of the carbon. So which has the highest number of the carbon? 4 carbon here, 6 carbon, 5 carbon, 4 carbon. So highest number of a carbon, hexane. Then the boiling point decreases as more branches are there. They all have the same number of the carbon. When we check the number of the branches, greater the number of the branches, lower the boiling point. How many branches? This have 2 branches. How many branches? This have 1 branch. 1 branch, no branch. So this has a maximum number of branches, so it has a lowest boiling point. Because more branches, smaller surface area, so it reduces the boiling point. Which solvent dissolve the greatest amount of a hydrocarbon? To dissolve the highest, it should have a same type of, because light, the concept is light dissolve light. So they have the same type of intermolecular force to dissolve. A butane 1-ol will have a hydrogen bond. Look, this is a alkane. Like this hydrocarbon is there, so this will have dipole induced dipole force. This will have hydrogen bond and dipole induced dipole. Ethanoic acid will have a hydrogen bond, dipole induced dipole, dipole dipole. Hexane will have dipole induced dipole, water will have hydrogen bond and like major force. So one which are identical here, dipole induced dipole and dipole induced dipole. So light dissolve by, if they have the same type of intermolecular force, then it will dissolve maximum. In question 10, which reagent could convert alcohol into alkene? So we want to carry out elimination reaction. So this is related to memorizing the condition for elimination reaction. So we need phosphoric acid if we want to convert alcohol into alkene. Elimination reaction. What is the correct name for this SO4 with a charge? So this is a sulfate ion, but what is the valency of sulfate? Each oxygen is -2, so 4 will be -8, so sulfur should be +4, +6. So it is sulfate 6 ions. So Roman 6 is, this is Roman 6, so sulfate 6 ion. If it was sulfate 4, then it will be like this. Because each oxygen is -2, 3 will be -6, so sulfur will be +4. Then it is a sulfate 4 ion, but this is a sulfate 6 ion. In which compound is oxidation number of a nitrogen is +5? When we take calcium nitrate, you can just take a nitrate ion here because nitrate is a valency -1. So each oxygen is -2, so 3 oxygen will be -6, so nitrogen should be +5. What about this one, the valency for magnesium nitrate? So nitrate is, because this will be -3 and magnesium is +2. In this compound N2O3, each oxygen is -2, so 3 will be -6. So this should be +6. So 2 are +6, 1 will be +3. And NaNO3, NaNO2, each oxygen is -2, 2 will be -4. Sodium is +4, so sulfur will be, so nitrogen will be +3. So that's why A should be the right answer. In which reaction copper species act as an oxidizing agent? Oxidizing agent itself, it is reduced, and reduction is a gain of electron. So means the copper should gain electron as the oxidizing agents are reduced. So which one, copper gain electron or reduced? You can check the valency. Here it is +2 and here it is 0. So if a +2 converted into 0, what we call this change, which we call this change as reduction. What about this one? This is +1 and here each oxygen is -2. So Two of the copper will be plus 2, each will be plus 1. So plus 1 remain, plus 1 no change. Here it is 0 and here it is plus 1. Like 2 are plus 2, each is plus 1. So this is also oxidation. But we want reduction because oxidizing agent, reduction happen. And here copper is 0, here copper is plus 2, so this also changes oxidation. But we want reduction. That's why A is the right answer. In a reduction, the oxidation number should decrease. What is the overall equation? To write an overall equation, we make the number of electrons same. So how to make, this is 2 and this one is 3. So this equation we multiply by 3 and this equation we multiplied by 2. So this equation we multiplied by 3, the other one we multiplied by 2. So this will be 3Cu plus, this will be 3Cu, this will be 3Cu plus 2 plus 6 electron. And the other one we multiplied by 2, so 2 nitrate ions plus 8 hydrogen ions plus 6 electrons. Whenever you want to write a combined ionic equation for a redox reaction, you multiply by the, like make the number of electrons same and then add the two equations. So when you add, this will cancel with this. So final result, 3 copper ion, 2 nitrate ion, 8 hydrogen ion will be 3 copper 2 ion, 2 nitrate, 2 NO ion and 4 water molecules. So that will be C. Then a titrate 13.25 was obtained using a burette. What is the percentage uncertainty? So percentage uncertainty is uncertainty divided by value recorded into 100. Whenever you are using a burette, because when we read a burette, we read the up, like we first read the initial volume, how much it was there, and we read the final. So uncertainty is always twice in case of a burette. So each reading has an uncertainty of 0.05, but this 0.05 will be multiplied by 2 because we read it twice. Divided by value recorded, so value recorded is 13.25 into 100. This will give us the percentage uncertainty of using a burette. So it will be B, 0.75%. When you, in case of a pipette, it is not multiplied by 2 because when we use a pipette, we read a single volume. But burette, we read the initial and the final and take a difference. That's why the uncertainty will become twice. What will the ionic equation? We cancel out the common ion in aqueous. So in this case, we don't, like, there is a OH ion, but there is no OH ion other side. So we just break down them into ions, the aqueous solution. So means it contains barium ion, it contains 2 hydroxide ion. This sulfuric acid contains 2 hydrogen ion and 1 sulfate ion, and it will form barium sulfate. Solid, liquid, and gas, we write them as it is without any change. And we break down the other ions, but there is no common ions to cancel out. So this equation will be Ba plus 2, 2 hydroxide, minus 1 gives 2 hydrogen ion plus 1 sulfate ion. Because we cannot cancel. Solid, liquid, and gas, we don't break them into ions, they will remain as it is. And here we don't have a common ion, so we cannot cancel out. 4 tests were used to identify the ions. A flame test, adding acidified barium nitrate, silver nitrate. So flame test, which test could be used for positive ions? Acidified potassium barium nitrate is a test for sulfate ion. Acidified silver nitrate is a test for halide, chloride, bromide, or iodide. Flame test is for the positive ions, and adding sodium hydroxide is also for positive ions. So which test could be positive ident of ammonium chloride? So ammonium, like it contain ammonium ion and it contain chloride ion. Ammonium ion we can test with 4 and a chloride ion we can test with 3. So C and D are the, because ammonium ion does not give a flame result and chloride ion give a white precipitate with silver. Which condition give the highest yield? We want to shift the equilibrium towards right and the forward reaction is endothermic. So if we increase the temperature, the equilibrium will shift toward right. For endothermic reaction, we should increase temperature. And about the pressure, increase in pressure shift the equilibrium towards side where number of moles of gas are less. Here we have 0 moles, here we have 1 and 1, 2 moles. So if we increase the pressure, equilibrium will shift toward left. But we want to shift the equilibrium towards right. So if we want to shift the equilibrium toward right, we should lower the pressure. So increase the temperature and lower the pressure, shift the equilibrium towards side of the product. Because if we increase the pressure, equilibrium shift towards side where number of moles or gas are less. So if we increase pressure, it will shift backward. So we want to shift it forward. So we should do it opposite. Nitrogen dioxide and dinitrogen tetro oxide exists in equilibrium. The mixture is pale. What is when the mixture is compressed, the color become. Look, when you compress, the molecules will come closer to each other. When the molecule will come closer to each other, even though when you increase the pressure, the equilibrium will shift towards the right hand side. So brown gas turn into colorless. That is what should happen. So first when you compress, what will happen? The particles come closer. Like in the beginning, the solution was pale brown, light brown. But you compress that, when you compress, the particles will come closer or the color will get darker. And then, because when you increase, as you're increasing a pressure, equilibrium will shift towards the side of the moles where less particles, so 2 and 1, equilibrium will shift toward the right hand side. So first when we compress, as the particles come closer, the color will get darker. But then the equilibrium shift towards right, then the color will get lighter. That's why C is the right answer. So this was Unit 2 MCQs from January 2022.